All right. So not only should you have a compass, but you should also have a straight edge too, because we're going to be drawing in segments and drawing in different shapes and all that fun stuff. So you definitely want to have a straight edge of some kind too. And remember, the more the stiffer the piece of paper, the more straight your edge will be. Definitely don't want to be hand drawing this stuff. Okay. So it's Thursday. Tomorrow you got a quiz. More than likely that quiz will include some. Truth be told, I saw it once and then it got edited after I saw it. So I haven't looked to see, but I think there are instructions on it. Just saying. Okay. All right. Should have plenty of time today to get homework stamped and questions answered and all that fun stuff. But we are in your notes. So let us begin. Okay. Construct two concentric circles with different radii. Okay. So let's talk a little bit about what there's all these different words in there. How many circles do we need? Two of them. Okay. All right. What do you think concentric means? Break down that word. It sounds similar to congruent, okay, but two congruent circles would be the same size. Okay? But let's break down concentric. What word do we kind of see in there? Center, right? So what do you think concentric means? So two circles with the same center point, right? Okay? So that's exactly what that means. Two circles with the same center. So the first thing that you got to do is you got to just pick a point, and that point's going to be your center. Okay? Then go around once, keep it in the center, and either make it smaller or make it bigger. And go around again. Okay? Everybody good on that one? Love it. Okay? Copy the segment below. We did this yesterday. What was the first thing we did when we copied a segment? We just drew a big old line, right? A big old segment already on our paper. We drew one on there. Okay? So we just drew a segment. What was wrong with it? What was wrong with it? What was wrong with it? Oh. Okay. Like, is it worn down? Okay. I'll go fix that one then. Okay? What's next thing we do after we draw just a big old line segment? Measure it with our compass, right? Oh, tap the brakes. Come back. Okay? So put the pointy end on one end. I'm going to go this way, because then that way I can actually manipulate it around. Measure out, right? Then go over to our line. and arc it. And then if I were to label it, I could label this point A and this point B, and then I could say that this would be point A prime and this would be point B prime, right? Or vice versa. Good to go on that one? Love it. Construct a segment 3 times as long as the segment below. I grab my, got to bring the compass with me. So what do you think we're going to start with? Big long segment, right? Okay. Big long, and you know it's got to be long because it's got to be at least 3 times longer than that one, right? Okay. Now what? Measure the small one. Okay. I like this plan so far. Whoops. I like this plan so far. Measure the small one. Okay. Then what? Arc the one that we've made down here. Okay. Repeat it. So put the pointy end at the arc. Okay. So do it 3 more times, or just do it 2 more times? 2 more times. So there's so that we got 3 total ones. And so then that would be it. And again, if we wanted to, you could erase, right? You could erase the extra part of your line if you wanted to, okay? But you don't necessarily have to. Okay? Yeah? All right. I'm going to shorten this up so we have room for a copy of the angle. Okay. Copying the angle. Start with a line segment. Then what? Arc my original angle. Whoop, did it again. Okay. So I arced my original angle. Same arc on the new segment. Where are you getting all this stuff from? Oh my gosh, you actually wrote down the steps yesterday? Like that they would be helpful to you? For a few of them? Okay, I get it. Okay. Right. So we have these notes so far today. Right now we haven't gone over anything brand new yet. Okay? So this arc, do I make it kind of big, right?
Yeah.
Almost all the way around? Because I don't know where that is gonna come in to play. So that one on that step number 3, that one I make a big arc. Okay? Alright? Now what? Yeah. So measure my pink arc up here. Okay. So I come up here and I Ooh, look at that. Same one. I like it. Okay. And then what do I do with that? Put pointy end down here on this intersection part. And arc the arc. And then connect. Pleasure. And then those are the same. Yes? Sweet. Right. Next page. I love it. Bisect the angle. We did this yesterday too, didn't we? Yeah. Okay. The next example, number 6. Yeah, number 6. I knew I couldn't get through everything yesterday because we only had 2 months. Yeah, so I got the heavy hitter ones. Yeah. Okay. Bisect an angle. What's the first thing we do? Arc the angle. Kind of like Hark the Herald Angels Sing, right? Okay. Arc the angle. Got it? Okay. So I should make it a little bit bigger though, right? So that it actually works out. Okay. So so touchy. Close enough. Okay, so then expand it out just a little bit. And then I go more. Then I go, whoa, that's great. And then I go a big old arc in the middle. Right? Then with the same length, right? Yep, with the same length. I go over to the other side. And I arc there. The vertex with my intersection point. Yupper. Okay. So that was a quick refresher from everything that we did yesterday. Okay. Maybe I would a little extra stuff with, getting a segment 3 times the one. Okay. So now let's talk about constructing an isosceles triangle that is not equilateral. Okay? So how do you think, so first off, we should figure out what an isosceles triangle is, what an equilateral triangle is, and what their difference is, so we don't make the bad one, right? Okay. Isosceles is 2 equal sides. Equilateral is all 3 equal sides. So we can't measure the segment and make the triangle that way. Okay? So we have to go with something different than that one. Okay? Alright? So how do you want to do this? How are we thinking? Let's think about this for a second. And I did see Anna's hand first. It was pretty simultaneous, but she was up first. Talk to me.
I think you could just go smaller or bigger than the starting line.
Okay, now how much smaller?
I think as long as it's smaller.
Okay. Can I tweak it? Gotta be more than halfway. Okay? Alright?
And then throw that in, and then do the same to the other side, like the other end of the line.
Okay. Can I go bigger than the line segment? Yep, because we don't want them all to be the same size. So I gotta go more than halfway, because if I don't go halfway, my arcs aren't gonna intersect, right? Okay? If I don't go halfway, my arcs don't intersect. Okay? If I go more than halfway, then my arcs intersect. With me? Okay? So if I go bigger than the segment, it's going to intersect. It's just going to intersect up at a little higher point. Okay? All right?
And then once you have like the two arcs where they intersect, you take your like through them, and then you
From the two sides? Yes, ma'am. Okay? So bigger than halfway, okay, but not equal to. Okay, let me just check to make sure I didn't go equal to. Yep, okay, I didn't go equal to. Bigger than halfway, but not equal to. Big ol' arc from one side. Okay? Then flip it around. Go to the other side. Big ol' arc from that side. And then, whoa. Connect. And connect. No. You just connect and connect. You only have to do one. It's not like a bisector where you got to do it on both sides. Yep. So you just do it's basically the same steps as a bisector, okay? Except you're only doing on one side of the line, not both sides. Okay? Construct a perpendicular bisector of the segment below. We've done that before, yeah? Okay? So, oops, I got to get my compi. Well, never recorded. Thought I hit it's on this. There it is. It is recording. Okay. All right. Construct a perpendicular bisector. How are you gonna do that? Ooh, talked enough, which is a good thing. Don't get me wrong. Okay. More than half line, and then big arc from each side. Okay, and then connect the two where the two arcs intersect. Okay, make that happen. Okay, arc bigger than halfway. Big arc from both sides. And then connect, right? That was weird. Mine didn't connect necessarily the right is must not have been my point must not have been exactly on the end point of one of them. Okay? Right? So now we know that this segment here is perpendicular, right? Which is good because we want to create a square. Okay? So how am I going to create a square out of this? I know I got a right angle here, so we should utilize that, right? Okay? So how I'm going to do this is I'm going to come over to that right angle intersection point. Okay? That's where I'm going to come over to. I'll shorten it up so that it's just to that length right there. Okay? Then I'm going to make an arc that goes between that one and that one. I'm making that green arc. Okay? Now my square is going to be there, there, and there. And let me get my compass out of the way so you can see that. Okay? So those, because this AB is equal to AD, because they're on that same arc length. Okay? Now we chose to go this way. We could have extended our line segment and gone even bigger if we wanted to. Okay? Now I gotta find point C. Okay? So what I'm going to do is I'm going to take my compass and I'm going to go over to point B, and I'm going to make my arc out here somewhere. Then I'm going to repeat that process at point D. And where those two arcs intersect, that becomes point C. And so then I see what's going on. It's a little bit on a tilt, the copy. So it's not, but it's close enough where it's centering it at the vertical and horizontal every single time. Okay? So ABCD now is a square, because I've got that one right angle. What's our last one? Whoa, tap the brakes. What happened? Come on back to me. Construct a rhombus. A rhombus? What's a rhombus? What do you got? 4 equal sides, right? Okay. All right. So, here's the crazy part. You get to draw another line segment that intersects with that one, right? If you have it intersect at the corner, great, or at one of the endpoints. If you don't, that's fine. Okay? It just has to intersect with this one in some fashion. Okay? Doesn't have to be. It can be whatever you want it to be. Okay? Okay? So that is going to be point A. We're going to bring our compass down to point A. And we're going to swoosh both of those segments. Yeah? Hi, Mrs. A.
Hi. Now,
Well-
what's different about you?
What's created was point B and point D. Mrs. A doesn't know.
It's your hair.
I know.
What the heck?
My kids have long hair,
I
and they
love
want
it.
to, and they got and they can put it in ponytails.
Is that
So
what you-
Christmas break, I said I want to put my hair in a ponytail, and so I have to grow my hair up now so we can get one picture. And then as soon as that picture gets taken, the clippers will be in my hand. Snap, zzz, zzz, and then I'll turn it over to Wifey, and Wifey will finish it off. So good. I know.
Sorry to interrupt you guys.
That's right.
You don't mind being.
Okay, so we swooshed it. That created point B and point D, right? Keeping the same. Do you see a pattern here between this and the square? Because what's a square? Square is a rhombus, right? Okay, a square is a rhombus. So now we go over to point B, and we swoosh the middle, or we kind of make a big old swoosh because we don't know where that intersection point's going to be. And then we go over to point D, and we swoosh. And there is point C. Yeah, fix this one. And there you go. And there's the rhombus. What are you confused about? Yours might look different, and everybody's could look different in all the. Well, because you probably went with this line, you probably went more up and down with it. Right angle or not? Yep. But a square is also a rhombus. Okay, and it didn't specify. Am I getting that one? I go from point B. So when I swoosh this one, I take that same length of my compass and I go to point B and I make this purple one. Okay? Then I go to point D and I make this purple one. And that intersection is point C. Okay? What's wrong? Well, it should be totally equal unless you got twitchy fingers and started twirling the dial on your compass, because the compass should be locked in. You know what I mean? Now, that's why we bought these. That's why we bought the expensive ones, because then you don't, like, when you're moving it around, it doesn't move, it doesn't open, it doesn't close. We bought the good ones for a reason. Okay. Side note: if you need to borrow a compass, there are Compassi in the resource center on both sides. On the support side, there's a bunch, and on the regular walk-in MRC side, there's a few too. Okay, right? So we have plenty in there if you need one. If you have your own at home, great, grand, wonderful. Okay, all right. A compass. These are expensive because they're high quality. But like you can go to Walmart and probably get one for $4. I mean, that's a long time. These are both fun. Yep. But they're also built to last too. The $4 or $5 ones, because they open and close so often, and kids don't know how to kids literally on the cheapo ones, when you're going around like this, like your circle will literally expand as it's going around, kind of a deal. And then they're held together by a screw up here at the top, and that screw gets loose, and then we gotta tighten out screws, or that it's like, oh, I can open and close it and pop that screw out, and so yeah, it's a whole mess. Okay, let's take a peek at our homework for tonight. Okay, so wait, this is last night's homework. For each regular polygon, use your compass to construct a circle with the same center as the polygon. That's going to be this dot here in the middle. That's going to be the center. That's where your pointy end is going to go of your compass. Okay? And then how far out are you going to expand your compass? To the dots. Yep. So you're going to expand your compass out to this distance right there. Okay? And then when you swoop all the way around, it should go through every single vertex. Okay? All right? So you should for sure get those 3 done today in class. Okay? Construct an equilateral triangle. So we talked a little bit about an isosceles triangle, right? Okay? How would I construct an equilateral triangle? It's got to have all equal sides, so how would I construct it? Okay? From each one. So pointy end on one side, measure it, swoop up, flip it around, pointy end on the other side, swoop up, connect. Sounds like a great plan. Love it. Okay? Construct a rhombus with side length AB. We've done that. Okay? We just did that. Okay? So we're good there. And then solving some equations, some algebra. Heck yeah! So in this next mod and a couple of extra minutes, I would focus on doing your constructions. Okay? Knock those out because then you don't have to worry about a compass. Okay? Get your constructions done right now. Okay? Have that.